One of the biggest challenges facing students of computer programming today is none other than the sheer number of programming languages and frameworks that they have to master in order to get a job. As such, it would be greatly beneficial if all these programming languages and frameworks can be simplified into one universal scripting language. However, is that even possible at all? If it is possible, then it would be a world-class breakthrough. In this lecture, we describe the bidirectional shunting yard algorithm. Bidirectional shunting yard algorithm, abbreviated as BISYA, pronounced as BISYA, which is a dual of Dijkstra original shunting yard algorithm and its inverse, and demonstrate using the reverse Polish notation as a universal script to interface to any known programming language. Dijkstra shunting yard algorithm was first published in a technical report on the then cutting-edge programming language ALGOL, spelled ALGOL, in the 1960s. It is perhaps one of the most important, if not the most important, of all computer algorithms. Unfortunately, many schools and colleges have pushed it aside under compiler design subjects, depriving students from knowing about it. It is called the shunting yard algorithm because the list of symbols consisting of operands and operators are moved in a T-shaped structure resembling the shunting yard in railways. Today's students who do not have opportunities to see a railway shunting yard may look it up on YouTube or just imagine a T-shaped junction where roads intersect. I chose this as the topic of today's lecture because by inverting the shunting yard algorithm, we can create a mechanism to use the reverse Polish notation as a universal script to interface to all known programming languages, thus making it much easier for students to master multiple programming languages, as well as enabling non-programmers to learn programming quickly, as well as use the reverse Polish notation to easily manipulate mathematical equations. As such, this lecture is intended for both programmers as well as non-programmers. For non-programmers, the crucial message from this lecture is that with reverse Polish notation, or the version we call PhosScript, spelled PhosScript, taken from the Greek word which means light, your programmer colleagues can no longer confuse you by making programming sound ultra mysterious. We shall briefly describe the principles of bidirectional shunting yard algorithm before we further explain how PhosScript may help non-programmers. As shown on the screen, we use a T-shaped diagram to illustrate Dijkstra shunting yard algorithm. At the top left is step 1, where the input tokens or symbols are placed at the top right branch. 3 space plus space 4 is what we would normally write, and this is also called the infix expression, spelled INFIX. What happens next are usually performed in the programming language compiler or interpreter, something even experienced programmers do not interfere in normal circumstances. The compiler or interpreter will examine the list of tokens or symbols. If it is a data token or operand, it will be pushed onto the data stack, represented by the bottom branch of T. As such, in diagram 2, 3 is placed onto the data stack. In diagram 3 at top right, if the current symbol or token is an operator, which is plus sign in this case, it will be moved to the top left branch as it needs to wait for 2 operands on the data stack that are both 3 and 4 to complete its operation. In diagram 4, at the bottom left of the screen, 4 is now moved onto the stack. There are now enough operands for the operator to perform the operation. The interpreter will now add the two numbers, pushing the result 7 back onto the stack, as shown in diagram 5 at the middle of the bottom of the screen. Now we have explained the first part of the bidirectional shunting yard algorithm. The shunting yard algorithm is the foundation of all programming languages, their compilers and interpreters. And I must emphasize again, all programming languages. So as you can see in the green box on the left of the screen, programming languages including but not limited to C, C++, PHP, Python, Java, JavaScript, use the shunting yard algorithm for the internal operations of their compiler and interpreters. Now let us look at the second part of the bidirectional shunting yard algorithm, that is the inverse shunting yard algorithm. As shown on the screen, suppose we now have an input expression 3, 4 plus, as shown in the bottom right green box on the screen. We will now apply the inverse shunting yard algorithm as indicated as step 1, pointing to the green box on the left. Since this is only a 10-minute short lecture, I shall not go into the detailed implementations of the inverse shunting yard algorithm, except to introduce the term for-script metaprogramming shell or meta shell. In Unix-derived operating systems such as Linux, a shell is basically a program that takes an input string and map it to programs written in various programming languages. Here, metaprogram means a program that modifies another program. Again, we will talk about the details later. Here we will introduce the sandwich API model, where we essentially turn the diagram in the previous screen into a vertical structure. In conventional API or application programming interface, the caller function and the callee function both use the same programming language. There are scenarios where a high-level programming language such as Python, Java, or JavaScript call a lower-level programming language such as C++. By introducing another layer of for-script metaprogramming shell or meta shell, as indicated by number 1 in yellow box, we enable programmers and non-programmer users to call functions written in any known programming language using for-script as a universal metaprogramming script.